All right, so what we're doing is we're combining 9 and 10, which is our last two sections of our Unit 1B, okay? So by combining 9 and 10, we're talking about all things rational functions. It's broken down into three parts. So you should have a part A, part B, and a part C. Part A is a little booklet. Not sure if I printed it correctly. I tried to print it correctly, so it should fold and turn into a little booklet. That was my goal. I tried really hard. Part B will be a little half sheet, and then part C is another booklet. Okay. Do we have all three parts of the notes? Awesome sauce. Assignment is due Tuesday. Okay, your assignment is 2 pages. The copier is out of staples, so it's separated. You can staple when you turn in, or you can staple before you go. Either way. All right, here we go. So, in our previous lessons, we defined rational functions as ratio of two polynomials, correct? And then we restricted from any values that would cause division by zero. So that would cause our denominator equal zero. And that's how we were finding our vertical asymptotes and our wholes. Okay. So just summarizing the characteristics is what this is about. So 9 and 10 are like a catch-all of everything, just putting it all together in all the ways that you could possibly see things play out. So vertical asymptote wholes of the graph both occur when the denominator values equal zero. A vertical asymptote is when it doesn't cancel out. I can't eliminate, right? A whole is when I can't eliminate, okay? Yeah. So the multiplicity is important to consider. So if it's just one factor, not a square, then you're only eliminating that one factor, not the entire. So we're going to look at it algebraically. So vertical asymptotes algebraically, when we look at it, we're analyzing what would make x minus 2 equal to 0. Does that make sense? So we're looking at our denominator, and we're saying if I set this equal to 0, where would my asymptote be? And where would it be? At x equals 2. So we would have a vertical asymptote of VA at x equals 2. Agreed? When we look at it graphically, we're asking ourselves, as our function comes from the left, what is it approaching? And as our function comes from the right, what is it approaching? So when we're writing that in limit notation, it would be the limit as x goes to 2 from the left. What is the function doing? And the function is going towards negative infinity, right? And then on the right side, the limit as x goes to 2 from the right, what is f of x doing? F of x is going towards positive infinity. All right, so therefore, we graphically can tell that there's a vertical asymptote at x equals 2, right? Because as it's approaching, the function are doing two different behaviors, right? It's split. All right. So far, so good. Yeah. Any questions, comments, or concerns? All right. On the other side, we're going to talk about wholes. Are these the right same now? I don't know if I have the same ones. I was about to be mad at myself. So here, when it's saying finding the vertical asymptote, is just making sure that you're summarizing how to find it. So algebraically, what are you doing? Graphically, what you're doing? All that good stuff. And just, again, paying attention to the limit notation. Now let's talk about wholes. Your wholes are what can be eliminated, what is removable from your expression. Okay. I got a hole in my graph. Like literally, it's the tiniest little space in there that you won't see. It's not as pronounced as we make it in our notes, but it is. When you go to the table, you're going to see error, error, error. Okay. So the main thing you're looking for is in factored form, what can be eliminated? X minus 3. I can eliminate x minus 3 from the numerator and from the denominator. So that means that it's going to produce a whole. Okay, so a whole is produced at x equals 3. Does that make sense? Okay, to find that value of the whole, you're going to use the simplified form of it. So after I eliminate, I'm left with 2 times x minus 1 over x minus 2. Makes sense? Okay, so to find the exact value of that whole, you're going to plug it into the simplified form, what you're left with. So if I'm looking for f of 3, I'm plugging it into the simplified. So that gives me 2 times 3 minus 1 over 3 minus 2. 3 minus 1 is 2 times 2 is 3 minus 2 is 1, which is why the whole is that f of 3 equals 4. Okay, you wouldn't plug it back into the original because it's going to make the 0 and everything's going to go away. No. It's like the projector. Oh, yeah, that's just the light. But if you sit from like the right angle, you don't see it at all. Like I don't see the glare. Yeah. You could also like if you just want to turn on the zoom on your computer, you can always turn on the zoom and then you don't have to look up. Just look at your computer. All right. So here we go. How do we feel? Doable? All right. When you're looking at the limit of this, as your limit is approaching a value from this way, this time it's describing what? As your limit goes to negative infinity and it just is approaching a value, this time you would be describing a horizontal asymptote, not the vertical asymptote because you're approaching y, your output, right? Horizontal can be your output, whereas vertical is your input because it's at x equal a value. All right, how do we feel about finding a whole algebraically and graphically? Doable? All right, let's move on. Okay, so in a rational function, when input value is 0 of the denominator and not a 0 of the numerator, the graph of a rational function has a vertical asymptote. We've agreed, we've learned, we've summarized that. Graphically, that's what these summaries are at the bottom. Vertical asymptote is vertical that your graph approaches, but is not a part of the graph, okay? It's that imaginary boundary line. It's approaching, but not going to reach it, okay? Because these are the values where the denominator would equal to 0, okay? The graph of a rational function will never cross a vertical asymptote, okay? We could say never with vertical, but we can't say never with horizontal. All right. So looking at these values here, and we're going to identify where it has an asymptote and where it has a hole. Make sense? All right, so let's see what happens. All right, so on the first one, where do I have a hole? Does the value like have to be input? Does it have to be the same squared on both? So what if there be a hole on both on the top of the x minus 2 and x minus 5? So we have a x minus 5. It would be a hole, but one still remaining in the denominator, right? So it wouldn't be a hole, it would be a what? An asymptote, because it still remains in the denominator. Did I eliminate it from the denominator? No, I didn't. Okay, let's talk about 4. So I eliminate 4 from the denominator, and it's still 1 remaining in the numerator. So what does that mean? Is there a hole? No, there's no holes, but we do have a vertical asymptote. And where's that vertical asymptote at? At positive 5, because we couldn't eliminate it from the denominator. Does that make sense? All right, let's look at f of x. So f of x, okay, do we have a hole? We have a hole at x plus 2, right? And why is it a hole there? It eliminates everything, right? Completely in the numerator and completely in the denominator. So at x equals negative 2, where else? At x equals 3. Because what happens in your denominator? There's nothing left in the denominator. We're only focused on vertical right now. Numerator would be if we were looking, sorry, we would be looking at a horizontal asymptote if we were talking about the degrees and comparing the degrees. So there's no asymptote. How do we feel? I can't have vertical asymptote, but there's nothing left in the denominator, right? All right, what happens here? And we got one left. Perfect. At x equals and positive 1. Because you have x and x minus 1 still in the denominator. Okay, so let's summarize. So for vertical asymptotes, so for our VAs, if the bottom degree is larger, notice that the denominator does not cancel out. The denominator factor does not cancel out. Which is why on the first one, you still had a vertical asymptote at x equals 5. Okay, let's talk about holes. For holes, if the top degree is larger, or top and bottom degrees are equal. Yeah. Is it? Because I thought of it as an x-intercept, but I guess you could have a hole as your x-intercept. So this is actually, yeah. There's a hole at x equals 4, even though it's your x-intercept. Would it also be there? Now I gotta go graph it. To the graphic we go. What? Yeah, there was a hole at the first one at h of x all along. Yep. Huh? Yep, we talked about it. You see it? Exactly. That's what I said. All right. So, are y'all ready to practice by yourselves? Oh, here you go, Bobs. So you're gonna do example number 1, A, B, and C. Huh? Example number 1, A, B, C, D. Huh? Yeah, I want you to tell me the holes and the vertical asymptotes. All right, so identify the holes. I'm asking you to tell me both. Just said that. Just tell me the holes, okay? Tell me the holes also. Well, the x values for any is x equals for vertical asymptotes. Yeah. So we're right, plus the holes. Okay? All right, go. I'll be walking around to assist. All right, here we go, really quick. So on A, we had a hole where? At x equals 4, and we had a VA where? At x equals 3, correct? All right. On B, what do we have? We have no holes, or we did have a hole? We did have a hole. The degree of the numerator is greater than the degree of the denominator, so there's still going to be a hole. Remember we just tested it and showed you with the 4?
There'd be a hole at x equals -3.
Because the degree in the denominator is greater. So your vertical asymptote is at x equals -3. So all you're left with is x minus 1 over x plus 3. All right. Next, factor. Okay. I was going to factor out first, but that's cool. I factor first. I forgot the square. There are none agreed. And I have one VA, and where's it at? Okay. I'm going to factor this first. What's the factor of my numerator? What's the factor of my numerator? X plus 3 and x minus 3. What's the factor of my denominator? X plus 3, x minus 3. All right, so therefore I have holes where? And a vertical asymptote where? At 2. All right, so how do we feel about VAs and holes? Okay. We can survive. All right. We have a quiz next week. Oh, no, that's this week. We have a test next week. Oh, I won't be here on the 8th. I think I have COVID already. What? All right, so now we're going to talk about putting it onto on a graph, being able to graph without the calculator, and with the calculator. So without the calculator, we should be able to say, okay, we know this much about the function, what the function is doing, the behavior of the function, and kind of be able to sketch it, and then to use the calculator as our, oh, you're such a smart person, you're such a genius, right? All right, so let's look at what we have. We have x minus 1 over x squared plus 2x plus 1, okay? So, yes, we do. So what multiplies to give me 1, but adds to give me 2? 1 times 1. Oh my gosh. Okay, x plus 1 times x plus 1. Agree? You so many papers had to print today. So, all right. So what values make my denominator equal to 0? What's the value? What is my vertical asymptote? X equals -1. Okay? That means that I have a vertical asymptote. We're going to go ahead and sketch that little bad boy in. Here's my VA at X equals -1. All right, next, the degree of my numerator is smaller than the degree of my denominator. What did we learn that meant? Anyone remembers? Last unit, the degree of my numerator is smaller than the degree of my denominator. What does that mean?
That means
It's a horizontal asymptote at 0. Okay? Because the degree of my numerator is less than the degree of my denominator, that means I have a horizontal asymptote, an HA at y equals 0, right? So here's my horizontal asymptote. All right, so these are the things we should be able to identify before we go to a graphing calculator. Are these things we are comfortable with identifying? All right, so I have what I consider terrible and devastating news. But bear with me how I explain it to you. All right, are you ready? So the AP board has decided that they will be incorporating Desmos into your test.
Yes.
It's terrifying and devastating.
Oh man, that's the worst thing I heard.
It's terrifying and devastating. The only hiccup is that they will be modifying the calculator, but we do not know how they're going to be modifying Desmos. So
Still use the TI-84, right?
yes, you will still be able to use the handheld, but it will be it's your FRQ is on paper, and you're still only allowed to use the TI-84 on the calculator part of the FRQ. Then we'll fight. I kid. Okay, but with that being said, because I don't know the regulations or the settings that they're gonna put on the Desmos, I don't want you to get used to having Desmos unlimited. Does it make sense? Because when you get to the actual, no. Because I don't trust y'all on computers when we're taking quizzes. So you want me to be honest? I'm gonna be honest. It is what it is. So do I trust you to only be on Desmos when we're taking quizzes and our tests? No, I don't. That's why we're just gonna still have no technology besides the handheld. But I do want to let you know that at home, when you are practicing, you are allowed to use Desmos just because it is gonna be a tool. In January, they're gonna give us more regulations on what Desmos would look like on Blue Book and what you'll be able to do with it. Okay. But calculator? A regular calculator?
No, we're saying like, what are you afraid that we would use?
I don't know. I don't know what y'all be doing with your lives. Yeah, you could Google, you could. If you're taking a paper quiz and I say you can use Desmos on your computer, you can do whatever. I don't know what you would do. See. All right, but I just want to let y'all know. So that was my terrible and devastating news that I felt like. Ugh. But anyways, graphic. So once you graph this, you're gonna see something funky happen. Let's see what happens. That's funky. And get a 0. All right, so I'm gonna go to Sylvie, good old faithful. I want to abandon you, Sylvie. Don't worry. You just hope you look like me and Sylvie when you get our age. Okay?
Get a new one. What happened?
I didn't click it, so I just had to push through, okay? Gracias. All right. So we're gonna go to graph. And notice the left hand is doing what we thought it would be doing. But what do you notice about the right hand? She did a little something strange, right? We're gonna zoom in on her a little bit. Go to zoom. I zoomed in. Notice that she did what? She crossed the horizontal asymptote. OMG. Okay. This is what I told you, huh? I just want to make sure we're all on the same page. That horizontal asymptote, remember I said we'll never say never for crossing a horizontal asymptote because there are situations where it will. What I've noticed as an educator, learner, student of math, I've learned that tends to happen when you have that double situation in the denominator, like a squared or repeated. So like this is x plus 1 squared. And so I've noticed that a lot of times that's when you end up getting that crossing of the horizontal asymptote. I've also noticed that when you have the imaginary situation, you may get it. But I'm sure there's a theorem somewhere that explains all the reasons and why, but we just don't have time to dive into that. We don't. It's not where we're at in line. So, but I did want y'all to see that we do cross it. And when we do cross, so on this side, we're following the asymptote. We're going. But on this side, it goes, okay, cool. We're going to go up a little bit to 2. We're going to go. And then we're just going to keep going. I know that's not accurate, but you get what I'm saying. It crosses. This is an example of where it crosses. Yes.
Why do computers now have no online Sylvie? I remember having one at middle school.
I have no clue, sir. I don't know. So like now when you have your limit as x goes to -1, because it's approaching the same value from the left and the right, we would just say that r of x equals -infinity. Because either way, whether I'm coming from the left or the right, what are they both doing? They're both going down. So the output values decrease without bound. You do? There you go. Isn't she glorious?
This one's great.
Well. All right. Limit. So this is summarizing everything we've learned thus far, tying it all together. The limit notation, left-hand limit, right-hand limit, the input versus output, decreasing and increasing with bound. All this is summarizing all the words and vocabulary that we've done so far. Okay? That's all it is a summary. Got it? Yes, you can always have another part of your notes. All right. Next. So here we're given the rational function. And it says we have x squared minus 16 times x, divided by x squared plus 8x plus 16. Okay. Where is the vertical asymptote? So the first thing we're going to do is do what? Did you say the most horrible thing? Just got to factor. So in the numerator, what does that become? What multiplies to give me -16, but adds to give me 0. There's nothing in the middle. A +4 and a negative. So you can see. And in the denominator, what do I have? An x plus 4, x plus 4. Okay. So where is my vertical asymptote? Well, I have you. And I'm still left with x plus 4. So therefore, my vertical asymptote is that x equals -4. So what it wants us to do is to analyze what's taking place as the function is approaching these said values. As it goes to -3.99999 and all these. So we're going to talk about how to do that in the calculator by changing the table. We will not betray Sylvie right now. If All right, so when I'm putting in the calculator, I'm putting in the values that I have remaining. I'm just putting in x minus 4 divided by x plus 4. So parentheses x minus 4 minus 4 divided by x plus 4, right? But I want to be able to put in specific values. In order to put in those specific values, I'm going to have to change my table setting. Change my table setting. I'm pressing second window. Again, I put in what was left. Agree? And then I'm pressing second window so that I can go from auto to ask. X minus 4 divided by x plus 4. You just had to use the division symbol. Okay, so now when I go to the table, I'm going to put in the values that I need. So our table needs negative 4.1. So I have negative 4.1, and I'm going to hit enter. Then I'm going to type in negative 4.01. So we put in our y equals. Then we're going to go to second window, and we're going to switch from our independent from auto to ask. Just the independent. So we switched our independent from auto to ask. Now when we go to our tables for second graph, we can now type in the specific values that we need. I know, it was so terrible. I know you want to complain. Okay, so now I have all the values that I need to fill in and make an analysis about this table. Yep. So I'm going to write down what we got. So we had 81, 801, 8001. Then we had negative, what was it? Yeah, negative 799, negative 79. So we're reading this for the values near and less than x negative 4. What are their outputs doing? So less than, what are their outputs doing?
Wait.
Less than negative 4 is going this way, right? Is decreasing, right? Is decreasing without bound. Without no. For the values near and greater than negative 4, what are they doing? They're increasing without bound. How do we feel about table analysis? You didn't even use it now. Okay. So when you're analyzing, you identify your discontinuity. So my vertical asymptote is my discontinuity, and you're choosing values that are super duper close to that. Does that make sense? Because if you analyze those values, you'll be able to see what's taking place over that window. Okay. Yes. Okay. I think I wrote this backwards, guys. Because we're getting near or coming from the left. Well, we're gonna read it this one. Coming from the left of negative 4, what are we doing? Increasing, so we're heading towards positive infinity. Coming from the right, we're doing what? Heading towards negative infinity. I think so is how they want it. I hate the wording here. I hate the wording. So I think we looked at it leaving from it, like heading towards, I thought it meant going towards negative infinity. Like if I'm heading towards negative infinity, what's happening? But now I see that too. Yeah, I see it now. I see where they're going. I did. I did some zeros. Yeah, so then it's saying as you're coming from the left, what's happening? And as you're coming from the right, what's happening? That's what it's asking. All right, so as we keep going, it's just more practice of bounds and increasing and decreasing and writing in limit notations and going back and forth. Yeah. So that we can try and get through B and C. I'm going to say that we're okay if we don't do additional examples of practicing finding the vertical asymptote, identifying the holes, and writing the limit. Is that okay? Does that say? All right. Yes.